Hi, now we're on part 2 of 2.4, which is the solving inequalities part. So right here we've got a box full of different values, and we are going to put those values in the box that they are a solution to. So first off, we have an equation, nice two-step, which is easy to solve. So I'm going to add 7 to both sides, and I've got 2x equals 22 divided by 2, and so I have x equals 11. So I can see that 11 goes right here in this box. Now, that means that on this one, x is greater than 11, right there, and this one is x is less than 11. So anything that's greater than 11, I'm going to put in this box. So that would be 11.01, 14, 105, 12, both 12s. Okay, and then everything else is going to be less than 11. So negative 5, 10.9875, negative 7,000, 1/2, 0, 8, and 5. Okay, so my strategy for this one was I solved the equation and then evaluate the solutions based on the inequality. Now that's certainly not the only strategy you could have used, but that was the one that I thought of first. Okay, so now we're going to represent the solution to each inequality on the number line. So we've got, this one is going to be x equals 11, x is greater than 11, and x is smaller than 11. So there's my 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now I'm not going to shade anything else because it's only 11 that is my answer. Okay, so this time 11 is not one of the solutions, but everything greater than 11 is our solutions. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This time 11 is also not an answer, but everything less than 11 is our answer. And patterns we notice, there's all kinds of patterns on here. I guess the pattern that I would notice most is that everything is used. So at some point in here we've got 11, everything bigger than 11, and everything less than 11. Okay, on this one right here, how does finding the equation or the solution to this equation help you find the solution to this? So like we did at the top, I can use the same answer but put an inequality sign in there. So I'm going to write that. I can use the same answer but substitute the inequality sign. Now, there is an exception to that, and I don't know if you guys remember when you did inequalities last year, but when you're multiplying or dividing both sides by a negative number, you have to flip the sign in the opposite direction. So that means that if my sign is like this, I couldn't just stick that sign in for my answer that was on the equations. So I'm going to put as long as I'm not multiplying or dividing both sides by a negative number. Okay, let's take a look at the next page. All right, so on this, we're kind of looking at the idea that inequalities have lots and lots of values. It says we will eventually discuss certain inequalities that have an infinite number of values. And we really already have discovered some or talked about some. If x is greater than 11, there's an infinite number of numbers that are greater than 11. And if x is less than 11, likewise, there are an infinite number of solutions to that. So a lot of inequalities have an infinite number of solutions. Okay, so in these, we are going to write an inequality sign based on the x equals that they give us. Then we're going to state another value, so another x equals that would make it true, and then one that would make it false, and that'll be C down here. Now, I'm going to do one as an example, and then I'm going to have you guys do one, and I am going to do the more difficult one here so that I don't do the easy one and then you guys are stuck with the other one. So here we go. So we're going to put in -2 for x. So we've got 2 times -2 plus 1 over -3, and then 4 times 2 minus 3 times -2. So all I did there was take out my x's and put in the -2 that they're saying is my x. And then I'm just going to use order of operations to solve. So I've got 2, -2 plus 1 is -1. Hang on, I put parentheses there and I shouldn't have put parentheses there. I apologize. Okay, so I've got plus 1 like that. So I have -4 plus 1 over -3, and then 4 times 2, -3 times -2 is +6. -4 plus 1 is -3. 4 times 2 plus 6 is 8. -3 over -3 is +1. 4 times 8 is 32. 32 is greater than 1. So that's the inequality that I'm using. Now, for B and C, there's a couple of different things I could do. I could just guess and check. So I could put in something for x and then see if it's true or false, and that would go on one of these lines, depending on whether it was true and or false, and then I could guess and check until I came up with the opposite. I'm going to show you how to solve the inequality and be a little more precise about it, but it's not necessarily a better strategy, it's just a different one.
Harley Johnson, if you're in the building.
Okay, sorry for that interruption. So we're going to take a look at this. So 2x plus 1 over -3 is less than 4 times 2 minus 3x. Okay, so I'm going to start by multiplying both sides by -3. So now I've got 2x plus 1 is, okay, so when we multiply both sides by a negative number, we have to flip the sign. -3 times 4 is -12. 2 minus 3x. 2x plus 1 is greater than -12 times 2 is -24. -12 times -3 is plus 36x. I'm going to subtract 2x from both sides. And so I have 1 is greater than -24 plus 34x plus 24 to both sides. And I have 25 is greater than 34x. Divide both sides by 34. So I have 25 over 34 is greater than x. So now, for my something that makes the statement true, which is B, I just need to pick something bigger than that. So 5. 5 is bigger than that. And then for my something that makes the statement false, oh, I'm sorry, I got it mixed up. So see how the alligator is eating the bigger number, so this is going to be bigger and this is going to be smaller. I apologize. So this is going to be x equals 5, and then the next one, we would make this something smaller than x to make it true, or smaller than 25/34. So I'm just going to say 0. X equals 0. Okay, so you guys go ahead and try to find the answers for this one. Pause it, and then I'll come back with the answers. Okay, so for this one, our answer is less than. And on this one, if you solved it, it would be x is less than -1/7. So anything that you had that was less than -1/7 would be true. Anything you had that would be greater than 1/7, so this has to be less than -1/7, and this has to be greater than -1/7. So I chose x equals -10, and I chose x equals 0. But as long as you're within these parameters, anything would work. Okay, please write down any questions for me that you have, and I will see you next class.